Good afternoon to everyone. I'm going to give some minutes and then we will start our last webinar of SHIP2FAIR. Good afternoon to everyone. My name is Alicia. I'm the communications manager of UREC. And in some minutes, in 2 minutes, I will start the presentation of our last webinar of SHIP2FAIR. So I'm going to give 1 more minute just to all the participants to connect to the webinar and we will start. Okay, so as I said before, SHIP2FAIR, our last webinar, is the perfect occasion to meet our technology providers, TVP Solar and Industrial Solar. And we also have a presentation of all the technologies. It's an overview of the technologies carried out by the project. And with this webinar, you will learn about the current options on solar heat technologies and how to integrate them in industrial plants through the experience of our SHIP2FAIR demonstration sites. This webinar is for you, whether you own an industry elaborating agro-food products, or if you are interested in optimizing your production through the renewable energy. And also, last, if you run an engineering company offering heating services based on renewable energy, it's the perfect occasion to learn about these technologies. So welcome to everyone, and I'm going to give the floor to my colleague, Aitana, who will present you the project. Thank you very much.
Thank you very much, Alicia. I think you can see my screen now.
Yes.
Right. Okay. Before moving to the core of this webinar, I would like to very briefly present the project in which these webinars are framed. In is the SHIP2FAIR project. There are many initiatives and programs and policies for the decarbonization of the industry, which is responsible of roughly 1/3 of the global greenhouse gas emission. And for this reason, it is crucial for the future climate to go for a near zero greenhouse gas emission industry. There are also key plans and innovation funds, such as the European Green Deal or the Horizon Europe funding programs, which are targeting sustainability of processes. And many of these actions or many of these initiatives are targeting the energy consumption in the industry because of its importance. And in the core of this context, we have the solar heat technologies applicable for industrial processes that stands as a sustainable option for a decarbonized industry. And this is in the end the objective of the project, to foster the integration of solar heat technologies in industrial processes, especially in the agro-food sector, and by developing and demonstrating a set of tools and methods that we will see in a second. This is a 4-year project, 10 million euros budget. And this is a brief overview or schematic overview of the tools and methods that we are developing and validating. First, we have a replication tool, which is a software, is an online platform, which is intended to support the concept design and the profitability studies of SHIP projects. In the end, the objective is to smooth these very first stages in the implementation of a SHIP project. We also are developing a control tool, which is intended to improve the control and to optimize the operation of SHIP installation. And it combines both supply data from the solar plant and also demand data from the processes in the industrial site. These two main tools are being validated in real demo sites, in 4 real demo sites that have or are in the process of the deployment of SHIP installation in their premises. We have a sugar boiling plant in Portugal, RAR. We have a meat processing plant in France, Lornody. We have spirits distillation in Italy, Martini, and a winery in Spain, Bodega Roda. And well, all the lessons learned, the best practices, and all the information that we are gaining within this project, we will gather all together in what we call the SHIP guide, which is an important outcome as well of the project, and will be available for the industry and for the academia, and also will be used in the training and building capacity programs that we are developing in the project. We are 15 project partners, including solar technology providers, research and development, and consulting, and also, of course, the active participation of agro-food industries. And now, as I promised, let's go to the key or to the core of this webinar, which is how to choose the right solar thermal technology for your industrial processes. And first of all, we will talk with Christophe Dumas from the French Alternative Energies and Atomic Energy Commission, and he will provide us an overview of relevant technologies applicable in the agro-food sector. And then we will have 2 technology providers of very innovative solar collectors applicable for the industry, such as high vacuum flat collectors, TVP Solar, and also Fresnel collectors from industrial solar. So now first, we have the pleasure to welcome Christophe Dumas. The floor is yours when you're ready.
So, thank you, Aitana. So I'm very happy to be here, and so I will share my screen. Okay.
Now.
Okay. So. So today I will talk about the different technology for SHIP and how to integrate them in a different way for the industry, and why and how SHIP can be relevant. So we will start with the energy needs in the industry, and so usually when we are talking about energy, we can say that the global trend is an increasing of electricity demand, and also an increasing of the cooling. But actually, if we look more deeper in detail, we can see that the thermal needs represent the half of the needs. And within this thermal need, actually only 10% is coming from the renewable energy, and only 1% from the solar thermal. So if we want to reduce the greenhouse gases effects, so we need to increase the share of the renewable energy. And there is a huge potential for solar thermal. And if we are looking more in detail about the share of the energy, we can see that the third of the energy here is dedicated for the industry. And within this third of the energy, 75% of the energy needed is heat. And 90% of the heat actually is produced by coal, oil, and gas. And only 10% is from the renewable energy. And also what is very important to see is the range of the temperature. And we will see after, and I will explain in detail why it is very important. And we can see that we can divide the heat into three sectors: low temperature, medium temperature, and high temperature. And low and medium temperature are very easy to address by the solar thermal. And this is why this target is very important, and we can address 50% of the heat of the industry. As I told you, the different sectors of industry are very important. For example, for iron and steel, the main share of the energy is high temperature, and it's very difficult to address this process or this industry. But for some sector, just like agro-food, we can see that low and medium temperature are required. And this is why we can target this kind of industry. And we can, if we are going much more in detail, we can see that the range of temperature is also depending on the process. And for agro-food sector, almost all the process are low and medium temperature, but mainly low temperature. But we can also address other sectors, just like paper industry, also textile industry. Chemical industry requires higher temperature, so it is just limits. It depends on the technology we can use. And we can say that for all the industry, at least we can preheat a boiler or produce cool for the process, or heat the buildings or the factory. This slide represents the different sector and the different range of temperature, low and medium, and the technology we can use. So for low temperature, we can use non-concentrated technology. And if we want to reach higher temperature, we need to concentrate the solar flux. So I will go much more in detail for each technology. So flat plate technology is commonly well known and used. So basically we have one flat panel with a manifold here, and the fluid transfer is flowing through the manifold and going into pipes in the flat plate. And we have one black cover, and this black cover it's the heat fruits. One other technology is vacuum tube, so we can go in higher temperature. So it is basically the same, but here the manifold is connected to different tube, and in this tube, this glass tube, inside there is vacuum, and we can limit the heat loss. So usually we need a slope, so it can be installed on roof or in the field. But sometimes we need to install them horizontally, and for that we have a variant here, and so done by produced by this man. And here the manifold and the collector inside can be tilled manually internally. So we can have the same slope regarding the latitude we are installing the plant, and it has the same efficiency. One other alternative is called CPC. It means it is a primary concentration collector. So basically, it is almost the same that flat panel. It is a mixed also with the evacuated tube, because inside we have one concentration, primary concentration with a mirror, and we can concentrate on a pipe for eating the fruits. So this technology will be detailed in the presentation by Dimitris from TVP. So it is a flat panel, but the difference is this flat panel inside there is a high vacuum, and there is almost not any heat loss, and the efficiency is really good, and we can reach higher temperature until 180 degrees. Then we are coming to the concentrated technology. So the first one is the parabolic through. So here we have one parabolic mirror concentrating the sunlight. So for that we need direct irradiation, and the sunlight are reflecting on the line, in the concentration line, and in this line there is an absorber pipe with evacuated tube usually, and the fluid is flowing in this pipe. This technology of concentration is linear Fresnel, and Irapua from Industrial Solar will give much more detail after. So basically we have line of flat mirror, but actually these flat mirror are not really flat but slightly curved. So there is one tracking, one single axe tracking, reflecting the sun on the pipe here with an evacuated tube, and we are concentrating the solar flux on this line, and there is a secondary mirror here, and on the absorber tube we can collect the heat. Last technology is dishes, and there is also one variant with tower. So the difference is here we are not concentrating the flux on a line, but on a single point. So this is why this technology requires dual axis tracking, and we can reach a really high temperature because we are concentrating only on one point. So why we want SHIP? Currently, the industry are producing the heat with fossil fuel, and if we want to take care about the climate, we can use the solar technology for a share of the heat production, and we can in this way, we can reduce the fossil fuel consumption, the cost, and also the dependency of energy. How we can do that? So basically, we have one solar field here, optionally one storage unit. So the solar field is producing heat, and through heat exchanger, we can send the heat to the process. There is different way of integration. So the first one, very basically, is to preheat the water. So we have here one collector, and the collector is heating the water and going into a tank, and the tank will feed the boiler, and the boiler will feed the process. There is one other way, is to feed directly the process with the solar field. So in this case, the boiler is in parallel of the solar field. We can also produce steam. So we can produce steam in indirect generation through a heat exchanger. But we can also produce steam, direct steam generation. So generally, we need concentration for that. And the steam produced is going into a steam drum, and we can separate the steam for feeding the process. As I told previously, we can also generate cold with solar heat. So for that, we need at least a temperature around 100 degrees. And the heat is feeding one absorption chiller. And this absorption chiller produce cold. We can have optionally ice storage, and this cold can feed the process if the process needs to be cold. This is another architecture of the for the cooling. So here it is a little bit more complicated because we can have a double effect absorption chiller. In this case, the coefficient of performance of the absorption chiller is better. But for that, we need a higher temperature because we have two stage. And for that, usually we need concentrated solar technology. So thank you. I don't know if you have some question.
Thank you, Christophe. It's been indeed a very comprehensive introduction to these SHIP technologies, and also a good overview of all the many configurations and type of collectors, and very useful to have a clearer picture of what this technology can offer. I would answer everybody, every industry can design and can apply these technologies in the processes?
As I told previously, yes, the technology can be addressed a very wide range of temperatures. So a lot of industry can apply for this technology. But for installing, for the installation and the design, we need well-trained people, and for that, this is one aspect of the project, and this is the reason why we are doing the replication tool and this webinar series. And also in the project, one of the outcome will be the SHIP guide, and we will give good rules for the installation.
Okay, we hope that this may help in the coming years to increase this low percentage of use of these technologies in the industry, because the possibilities are huge. Okay.
Yes, really huge. Thank you.
Yeah. Thank you, Christophe. Now, following the agenda, we have Dimitris. from TVP, and he will explain a little bit more into detail about this innovative solar collector, which is the high vacuum flat collector. Christoph, Dimitris, sorry, when you're ready.
Thank you, Aitana. Yes, I'm ready. I'm sharing my screen. Just give me a few seconds. So I guess that now you can see it and also in
Yes.
presentation mode, correctly?
Yes.
Good. So thank you all for joining. Following Christophe's presentation about the different alternative technologies, my presentation will focus on the technology that my company, TVP Solar, has developed over the last 10 plus years. It is the so-called high vacuum flat panels. And I will give you some background information about this technology, as well as about some details on it. So TVP Solar has been was established back in 2008 in Geneva. And the reason for this is that one of the co-founders was working at that time before at CERN, where he gained experience on high vacuum technologies. And based on this know-how and experience, the company has been incorporated to develop high vacuum flat panels, meaning that we are coupling, we are we are using flat design in combination with high vacuum, so that we can improve significantly, drastically, the overall efficiency of the solar collector, which is a non-concentrated solar collector. The technology is Solar Key Mark certified to deliver heat from 65 degrees Celsius up to 200 degrees. Typically, the ranges of the applications, the systems that we are running, ranges from 80 degrees Celsius up to 180 degrees. There are a lot of different technology innovations embedded in this panel. One of the major ones is the glass to metal seal, which ensures that the high vacuum inside the panel will remain there. And there are also some internal pressure indicators that can provide a visually indication if the vacuum has been deteriorated or destroyed. Some further innovation has to do, an important one has to do with the getter pump. You can see on the bottom left the panel. This device aims to absorb gases that may be released by the metal parts of the panel within its lifetime. So with this device, we can also guarantee that the vacuum will be remained at very low level throughout 20 to 25 or even more years. And thanks to these different type of technological innovations, we can ensure that the heat losses, the conduction heat losses in the panel are minimized, meaning that in that sense, almost all heat generated from the sun is being channeled to the heat fluid, ensuring high efficiency. Now, this is just a slide summarizing the 10 patent families that we have. 177 of them are already granted. And here on the On the right side, you can see the different target applications, application areas that we have. Our solar collectors target industrial scale applications. So you will not see them in small households unless it is for research purposes. And as you can see, we are of course targeting in the food and beverage dairy industry, but also other type of industries that have thermal needs at the temperature range of 80 to 180 degrees that I mentioned before. Some different processes that we can feed with hot water or steam up to 4 bar are sterilization or pasteurization processes, drying, washing, cleaning processes, etc. What we are actually providing as a value to our customers, industrial customers, is first of all relatively cheap thermal energy. And I will give you some examples later on. The opportunity to achieve their sustainability targets towards decarbonization. Our solar heat is carbon free for the generation of heat, as well as we can guarantee that the solar system will keep running for 20-25 years. We provide a guarantee for 20 years, but we actually believe that the lifetime can be even higher of 25 years. Now, you can see also that the target cost of energy is just 3 cents of the US dollar per kilowatt hour. This is the target price for very large scale systems. Here in these two diagrams, you can see a comparison between our panels, our technology, and other products from different technologies. What we are trying to compare is for the temperature range that we are targeting at. We would like to demonstrate that we are significantly more efficient. And you can see that for these two different diagrams, we compare one on the left diagram is the comparison for full sun conditions, whereas on the right, the diagram provides a comparison for the average daylight. So what you can see here is that at average daylight conditions, our panels are comparatively even more efficient to other technologies, and this is exactly because of the high vacuum and the reduction of any conduction heat loss. Typically, the range, so the improvement in the efficiency could range between 30–50%, or in some cases even more. Here is a comparison of the price. On the green, you can see the target range for our solar heat. And you can see that we are cheaper at annualized basis, of course, compared to liquid fuels. In most cases, I can say, at least in Europe, that we cannot at this stage compete yet purely economically with natural gas. But taking into consideration the carbon tax in Europe, but also the fact that fossil fuels prices may well rise in the following years, I think we offer a quite reliable and stable pricing throughout a 20 years period plus. So it's quite competitive. Of course, there are some issues that we might also discuss later on. Here is a map of the solar irradiance across the world, and a table that gives you a glimpse of what we can produce in different levels of solar irradiance. Now, as far as the competitive advantages, I will just summing up them here. We are cheaper than liquid fuels. If we have some subsidies available as well, then we can be competitive with natural gas. We provide high efficiency solution for temperatures between 80 and 180 degrees, independent of solar irradiance conditions and geographies, more or less. And there are no tracking equipment, no major moving parts, and that's why we keep the operating costs at very low level, and we can be installed. The systems can be installed in both on top of roofs or on the ground. Compared to fossil fuels specifically, again, we are fully decarbonized. And this is the major advantage, taking into consideration the energy transition, the Green Deal, and the decarbonization targets for Europe, but not only across the globe. Now, in this diagram, you can see the curve in blue that is has been certified by Solar Key Mark, whereas in the red dots you can see the actual performance of our collectors in a real conditions, in a real system, and you can see that are more or less fully aligned with the Solar Key Mark certified performance. Our systems, in terms of layout, we are trying to standardize them, and we use a modular architecture so that we can scale. There are strings of solar panels that are connected through a main core tube that circulates the hot water or to the heat exchanger that provides heat to the processes, to the thermal network of a company and the processes. Here in this diagram, you can see the different integration strategies, solutions for our systems. In case that we cannot meet the high temperature and pressure steam at 10 bar, it's high pressure for us. We can provide hot water for preheating of the boiler. In case of lower pressure steam, we can provide steam through indirect steam generation, or at lower temperatures, we can provide, of course, hot water at process level. Now I have some time. I will go very quickly through a few examples of reference projects. This one is in Saudi Arabia for Saudi Aramco. You can see that it operates at 160 degrees, even with mud covering, dust covering the panels. Here you can see an interesting example from the other side in Geneva, a solar district heating system that can provide heat at 80 degrees Celsius in February morning, even with half of the panels being covered by snow. On the top left, you can see one of the demonstration sites in SHIP2FAIR project in Martigny Rossi in Turin, north of Italy. It's an interesting, very interesting demonstration because we run in a dual mode. During summertime, we provide steam, whereas during the cold period from October to March, we provide hot water for space heating. So process heat during summer, hot water for space heating in the industry during the cold period. It is interesting also for this specific, so this demonstration on Martini and Rossi, the different control strategies and that we will apply based on the control tool of SHIP2FAIR. So first of all, our system is configured to operate in a specific set point during the summer period and a different one during the winter period. This set point can dynamically be changed based on the weather forecast. So if we are, for instance, in March and we typically operate for space heating, but the weather forecast shows that we can produce steam, then the system can shift to steam generation so that we can provide steam to the industrial processes. And this will be feasible thanks to the control tool that is being developed and is being applied nowadays through SHIP2FAIR. Finally, I will not go through this. I just wanted you to draw your attention to the solar key mark certificate, where you can see for different conditions, for different solar irradiance conditions and temperatures, what the certified efficiency of our system is. And with that, I will end my presentation and give the floor to Aitana. Thank you.
Thank you. Thank you very much, Dimitris, for this very, very detailed information about these innovative collectors and all the technological innovations that they contain. And what about the level of penetration and the potential barriers that one can face when talking with about these collectors?
Well, this is a very interesting question that we have made quite a few times, and Irapua can also help you on this with his own perspective. I think that one of the major barriers, if not the major one, for the penetration in the process industry and food industry specifically, is that engineers and managers in the industry are not familiar with solar heat. So, also solar heat and decarbonization, it's not, or at least since very recently, it was not among the top priorities of the industry. In that sense, it is not a priority for them to decarbonize and to test new technologies. But things are changing. This is very clear. We may not know how quickly the penetration of solar heat will skyrocket, but this is, from my perspective, something that is imminent, taking into consideration also the policy priorities of the European Union and not only concerning decarbonization. Also, what I would like to mention is that there is, in the last few years, a flourishing in the solar district heating market. And this may have also a positive effect in solar heat for industrial processes, because engineering companies, construction companies become quite familiarized with solar heat. And sooner or later, we'll search for new markets to apply these solar systems. And I think this will give us also a further push. There are quite a lot of other issues that we can discuss, but I would like to leave the floor also to Irapua, and then we may have a more interactive way of discussing these issues. Thank you.
I couldn't agree more with this lack of familiarity of engineers about the technology, and also the increasing level of importance of decarbonization in this industry, that it will be a clear path in the close future. Thank you very much. Now we have Irapua. from Industrial Solar that will explain to us a little bit more details about these also very innovative collectors, which are the Fresnel. And Irapuá, the floor is yours.
So thank you, Aitana. Thank you also for the introduction. Let's see if my screen is appearing for you.
Not yet.
For me, it's showing here. It should come now.
Yes.
Right.
Perfect.
So great. So thank you again, and I hope that the audience is finding this discussion very interesting. It's a very hot topic, not because we work with high temperatures, but because it's also exciting, interesting in many ways. I'll go through a slightly different approach for producing solar heat differently. I mean, because we use concentration, but at the end, the main goal is that all the industries, they need heat. And as Christoph also presented at the beginning, there are different and several ways. And we, the industrial suppliers, we are ready to provide these technologies. So I'll talk today about the Fresnel technology. So I'll start talking about the technology itself. Then I will speak a little bit about the demo site that we are building in Portugal for RAR refineries. So let's get started. So basically what you see here was slightly presented by Christoph as well. We have a collector technology that basically uses mirrors, as he already mentioned, to track the sunlight. And as you see here in the animation, the sunlight is always directed to the same point, which is a pipe, long pipe. You're seeing here 3 modules, but we typically connect these modules in long lines in order to increase the power. And therefore, we can generate directly steam because we have this high concentration of energy in one point. We made a system that is modular, so which means we can make strings from 8, 16, 20, 24 modules. So it depends on the area, we can organize the modules to fit. We can also install on roofs or ground. The structure is lightweight enough to be installed on roofs. As you see here, our specific weight is 27 kilograms per square meter, already considering the fluid. What is one of the big points of the technology is that although it uses concentration, at the same time, it's light enough to be installed on industrial facilities, but also generates the high temperatures that you would typically see in the CSP power plants, which are normally installed in ground and desert areas. So it can generate up to 400 degrees Celsius if we use thermal oil. We can also use steam directly, which I will talk more before at the end. And we can also heat up pressurized water at high pressures. We have systems operating at 180, 200 degrees Celsius already for some years. And the lifetime of the system, it's good enough for any industrial client to invest. The system operates without problems for several years. So mainly the main components, because it's not only a collector, it's a system. So I'm showing here some parts of this. You see the structure. In this case, this project we made is in a rooftop, as you can see here. These you see the mirrors, but you see only the back face of the mirrors, which it's, as Christoph mentioned, it looks like flat, but it's not really completely flat. It has a slight grade, but it's flat enough for cleaning manually if needed. There is absorber tube, which in this case is evacuated. Therefore, you have the high efficiency and you can generate the high temperatures that we propose. And there is always the control system. And I will talk a little bit more about the control tool that is being developed by the SHIP2FAIR at the end, which is integrating our control to the control tool for the plant. So one of the main advantages, because I always compare these with the parabolic collectors, because the concept of the Fresnel was an idea of the parabolic, but actually you cut the mirrors in slices and then you get a different organization, like a different setup. But there's some differences, and one of them is that the ground space efficiency, for example, for 1 megawatt of this system, of the Fresnel system, you can use less than 3,000 square meters of ground area, already including the the walkways. There is the low wind exposure because the mirrors are very low in the ground, half-meter high only. And the mirrors have all the positions as you see. For example, if there is a storm, the system can withstand storms up to 180 kilometers per hour. And that means the system is not going to be damaged. There is also a good weight distribution. So the collector has different foods, so you don't have a concentration of weight in a certain point. The automation in the operation is very important because there's no need for anyone to be on the ground to start the system and stop the system. It detects, there is a weather station that we call. It detects already the solar irradiance, and then at the same time the system starts tracking, and then at the end of the day the system goes back to stall position. And also because the mirrors are always changing, and at the end of the day going to stall position, the accumulation of dust is much lower than other collectors, because you see here, for example, they also have like the self-cleaning. So if it's raining, the collector detects the rain and also cleans itself, or helps to clean, which is also a feature, depends on the climate where it is installed. So if you were participating in the last webinar we made, I slightly started this topic of how we generate steam. If for you, this might be new, so I can explain in more detail now. So basically we use the makeup water, which could be the same used by the boiler. Actually, we use the same pipeline and connect it to the collector system. And then we have the irradiance concentration. So you increase the temperature. At the end of the collector, there is a mix of steam and condense and hot water, which can also be the same temperature as the condensate. Then you have the steam storage where you separate this. And at this point, you go with the steam for the customer, because the steam drum, I will show slightly later how it works. You can separate both and then deliver the saturated steam at the same pressure as the boiler is providing for the industrial process. And the cycle closes because we have a recirculation pump also coming from this system. So that is what I was mentioning before. So this is how the steam drum works. It's not a nice to have, it's a very important to have feature in the system, because at the same time it separates the mixture of steam and hot water. It also delivers the steam at the pressure level required by the process. And we have also the working this as an expansion vessel. It's also used for blow down, for deaeration. There is also the case for antifreeze protection in some areas where the temperature can drop below 0. So all these functions are provided by this. Therefore, the system can operate all year round, as long as, of course, there is solar radiance. And this is what you see in a real scale project. So you see here the steam drum, you see the collectors here behind. So the steam is delivered by the top, and the recirculation is coming from the bottom to the collector field. And here I can go quickly how the performance of the system operates independently, because you see different lines. In this case, there is a customer operating a steam grid at 4 bar with a fossil fuel boiler. And then at the same time, we start receiving the DNI, or the radiation, and then we have the pressure in the steam drum increasing, as you see here in the morning. In this case, this day, the sun was starting very early. And then the system starts already pressurizing, and when it gets to the certain pressure threshold here, then it starts delivering steam at a very stable pressure, what you see here in the purple line, at 6 bar. And we, on purpose, we operated as a slightly high pressure for our valve opening, because we avoid the boiler to be doing what it was doing before here, which means modulating to keep the pressure, because the system is delivering the steam, and the temperature is also very stable. In this case, we reached 200 degrees in this day specifically for this system, and the system was constantly delivering steam at 6 bar for the customer, which is what they need. So how we apply this? So as Christoph already mentioned this, I won't go long, but this is basically the market that is for this technology. So which means all the processes is you see here from this 74% that Christoph commented, 52% it's from temperatures that this technology can cover. It's more than half, and it's a very big piece of the cake if you look at the total energy demand. There are several industries that can be applied as we are doing the SHIP2FAIR for the food and beverage and agri industries, but also for textile, pharmaceutical, paper, automotive, oil, chemical, and for different processes. I won't go in details, but the integration can be in different ways and also using different heat transfer fluids. So I'll go quickly now through the project at RAR. So RAR, as you probably, for the ones who watched the first webinar, RAR is a sugar producer based in Portugal, in Porto. And in their case, they need a lot of heat for their process of sugar crystallization. And they typically have two main steam grids that they use. So one at 1 bar, one at 5 bar, which is very comfortable for the technology because the system is pressurizing for operating slightly longer, as I'll also comment later. And then this is how we design the system. In this case, also for a rooftop installation. We are installing 30 modules because of the constraints they have. The orientation, as you see, it does not matter for the collector. You can install it, as you see, 47 degrees. It can also be oriented in the other direction, or north-south, or east-west. The difference in the energy yield, it's very minor. And the system, in this case, we will store in the steam drum, as I commented, at 10 bar. We are at the moment at the engineering, and this is what you see here. So we have 2 strings of 50 modules for their project, and they are connected in series. So we are generating the heat in the total, let's say, 30 modules line, and then it goes back to the steam drum. The peak power of this system is going to be 415 kilowatts, and as you can see here, the space efficiency is very high, considering that is a concentrating technology. And this is how you would see it. Hopefully you can visit the system, and for the ones interested, next year we'll have visits organized to visit the system on the roof of RAR. So it's going to be the 2 strings, as you see. They are in different levels, and the steam drum is going to be installed on the side here of the parking area. And this is what also we are bringing as innovation for this project, as we are making the modularization of the installation. So we will bring all the pumps, pipes, and all the periphery, which we call the BOP, balance of plant. This is going to be coming in a container, and we will have the steam storage over it. So it's very space efficient, as well as it's fast to install. So everything will come pre-manufactured, and just the connection from the collector field to the BOP is going to be made on the field. And this storage has a capacity of 1.5 gigajoules, which is the 1 hour of operation of the system in the peak capacity. So this is how we deliver steam for the processes in the RAR case. Now I'm showing a simplified diagram. So RAR has the boilers, and they are operating for the different consumers. As I commented, they have the 2 different steam lines. And we are taking the water and the mix of water and condensate, because they also have there the same level that is supplied to the boiler. We are taking this for the collector field. And in the collector field, we heat it up, and then we separate the steam from the hot water, and then they deliver the steam. And as this is a pressurized system, so the temperature here is always high, and high enough that even if the sun is not shining, the storage, the energy stored here, can be supplied, because it's a flash evaporation that will happen in this system. And the only limit will be when the pressure drops, and then the volume of water drops in the steam drum, and then the system will shut down this valve. So this will be the case, for example, because they operate from Mondays to Saturdays, but they don't operate on Sundays. Therefore, the energy stored on Sunday will be used for the startup on Mondays. Normally they have a delayed startup on Monday mornings because the system stops on Saturday and starts on Sunday evening and the early Monday. Then the system, the steam system, of course, if there is sun on Sunday, the system will still have energy enough to start the whole processes. And when the boiler preheats and then get the pressure needed and then it starts producing, they can reach their full capacity with the boiler as they do nowadays. But this delay of startup will increase their efficiency and their production, because the solar energy from the sun, they will be used already for the beginning of the next day, in this case, Monday. So what we are taking advantage for the control tool, and this is very important for us. So our system has already a weather station, but we are integrating with the control tool so we can help to predict what the system is going to produce. And it's very important for the customer to know what is coming for the next days, which means the forecasting. And this is an algorithm that is being implemented in the control tool to predict and optimize this. It's very important to integrate and know also how often and how much is being used by the plant. So this integration is also being made here. And at another level, it's integrating with the control of the plant, and the plant owner can see everything. And it's important to learn what were the problems, when we can optimize some processes. For example, this startup on Monday or shutdown on Sunday or Saturday, everything can be seen and optimized by using the control tool. So because about the technology, I already finished. I want just to invite you, if you are interested in having a case studied by us, to participate with the replication tool. It's a very important tool that Aitana presented at the beginning, that we will analyze and make a free assessment for selected industrial sites. And if one of you from the audience are interested, please drop us a message at this email or text in the chat box as well. So what this replication tool will do is like a technical economic assessment. By giving some very basic information, you can have a free assessment and know how much energy you can get out of this and which technology is the suitable for your case. With that, I finish, and thank you for your attention.
Thank you very much, Irapua, for this, again, this very detailed information about these pretty innovative collectors and how they can provide steam to the industry, which is very, very used. And I'm sorry, but here we have a terrible storm, and I don't know if it's going to happen something, but and as I said, and also thank you for the remind about these 10 additional use cases that we are going to analyze for free using the replication tool. And just please use the regular channels of the project to communicate if you are interested on to obtain this pre-feasibility study for your premises. And what about the same question that rise to the methods, which are the main, what would be the main barriers for the implementation, and maybe which is the level of penetration of these technologies right now?
So the level of penetration, I think, for most of the solar technologies, besides the domestic hot water, is very low. And we see the worldwide market, it's growing, but very slow compared to the PV, which is really picking up quickly and fast. And most of the cases, and what I experienced, for example, yesterday I was talking to Peruvian companies, is that most of the industry or industrial managers, they don't know that these exist from the beginning. They have no idea this exists. They think that solar energy now is only PV, you can produce electricity. And when you show them that they can produce heat, and they say, but it should be obvious, but it's not, because it gets hot outside, but they cannot relate. This is one of the points, but most of this problem is also as they don't know this exists, they don't know how much they can benefit of this. So for example, if you look at a factory, sometimes, for example, a textile factory, and they have 20,000, 30,000 square meters of area available, and they don't know their solar resource, they don't know how much energy they can generate there. And if any plant owner knew that these technologies exist and know the potentials they have, they would definitely at least look at the alternatives. Even if they don't decide now, they would do it. But this is on the, let's say, putting the hot potato in their hands. But on the other side, there is also the problem with the, let's say, with the government support for these technologies. We are now, for example, the SHIP2FAIR project is one of the few projects we have worldwide promoting solar energy, especially for industrial processes. And there is a lot of support for several things, but not for this. And we saw that this is 30% of the problem for climate change. So there is no support, and there are different ways to do it. For example, France did in a way, Spain did in another way. For example, with the studies of the markets, in France there are subsidies. In Spain there is also starting now. I think now in Austria.
But they are quite intermittent.
They are intermittent. They are not constant, and the problem is that even when they exist, the plant owners don't know they are there, so they cannot take advantage of this. And nevertheless, there is still a lot of support for the fossil fuel industry. And because they are still the mainstream, and this is not to say that's unfair they are mainstream, because they are older than these technologies, it's kind of understandable, but they don't need that much help or that much support as the new technologies need, especially because, as Dimitris commented, we are not doing projects for households. We are doing projects for the industries, so they need scale, and needing scale, they need to have more projects. For example, for any country, if they want to see when this is working, it's like buying a car. If you never saw a car, you would not buy a car. And the same for these technologies, that it looks amazing, but how much is this? And does it really work? And regarding the economics, it's always a common question, but this is expensive. Well, that's expensive depends on how you look at it. Because if you look at this year, maybe it's expensive, but if you look at 25 years, it's way, way cheaper than what the business is already doing today. So I think these are, in my opinion, the main barriers on both sides, not only in the, let's say, in the public perspective, but also on the government support.
Yeah, there are many, as you pointed out, many points to improve. The first, the knowledge on the industry, in which we are trying in the project to improve this knowledge and to support the widespread of these technologies, and also by the replication tool to smooth this first contact with the technology, and okay, how much can I take advantage of these technologies in my plants. And also from the governmental side, there are subsidies, as we were talking, but they are not regular, they are intermittent, and also the plants don't know what to do and what these technologies can offer. Very interesting analysis. I don't know, Dimitris, if you want to add something.
Well, the penetration rate is so low that the only way is up.
Exactly.
Can only
Very
grow.
optimistic.
Yeah. What I would like also to complement in relation to some questions that have been put in the Q&A and chat. First of all, there are different business models that we can apply. I think also industrial solar as well. So the more conventional one is turnkey installation. So we provide the system, we commission it, and the client pays for it. And the second one, which is distributes actually the cost of capex within a much larger duration, is for the customer to pay based on the consumption of heat, and of course in line with some long-term contracts. So even if the costs may seem quite high at the beginning, there are business models that they can be used so that the customer can pay bills that are lower than the ones that they pay with, for instance, if they burn liquid fossil fuels in a boiler. For the subsidies, I think it's also starting to become more and more popular to have national or regional subsidies for solar thermal industrial scale. I know, of course, in Austria, France, Spain, and quite a few countries, Greece is going going to have hopefully this year. And we have also to take into consideration that the carbon tax through the European ETS system is also channeled through the Innovation Fund to support up to 60% very innovative projects. So if there are some really innovative projects, and this could be in the area of solar thermal, definitely, then we can have funding at European level. Another point I would like to raise also that Irapua also touched upon it is that the actual if we use just the solar system itself, we can cover 10 to 20% of the thermal needs of any industry, especially if they operate 24 hours a day and during the weekends as well. So we need to develop cheaper and more efficient storage solutions for especially steam, which are not, at least to my understanding, really mature today, so that we can increase this share of solar heat to much higher percentages, but even to 100%, at least in the future, hopefully in some cases. One major barrier for this would be, of course, the availability of space. We need space to collect the sun irradiance. So if there is no space, if it's in areas where there is density and with buildings, then we might not have this possibility. But of course, we have to look each case with its individual particularities.
Yes, of course, it's the very first step. Thank you very much to you all. I think we are a little bit out of the schedule, but in any case, the discussion has been very, very interesting. And now I think it's the turn to Alicia. Alicia, I don't know if you are there.
Exactly. Can you see my camera? Can you hear me?
Yep.
So give me a second. Thank you very much to all the speakers for this magnificent presentation. It was really interesting, and I think also for the participants know what are the technologies that are implemented and can be implemented. And as the last task of today, and in order to keep the time as much as possible, I'm going to show you the last version of our leaflet. And you can also download it from our webpage. I'm going to remind you also that after this webinar, you can download the recording of all the webinars, including the last one. You can also download it from our webpage, and we will send it to you through the email. So last but not least, I'm going to share my screen to show you the leaflet. Can you see it? Can you see my screen?
Not yet.
Not yet.
Not yet.
Okay, now?
Now it's coming?
Yep.
Okay, so as you could see, this leaflet was more focused on the demo sites and the replication and control tools, as we and our partners explain through this webinar series. So our project, it's a project focused on the solar heat for industrial process, as my colleague Aidan explained to you. We have the replication tool, which is a software created to support the concept design of SHIP projects. Then our colleagues also explain the control tool. And here you have the 4 demo sites implemented, the one from that are already implemented and the one that are going to be implemented in the upcoming months. And for more details, we will upload this document on the website. I don't know if you have any questions or if you want to add something, just feel free. I cannot show the second part, but you can download it in our webpage. So this was the update of the leaflet, and thank you very much for the participation, and thank you very much to the organizers for this great webinar series.
Thank you very much. Bye.
Thank you, everyone.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye.
Bye.